I already have one of the questions that you guys sent to us, and this one comes from Mpendulo Pai. A very beautiful question indeed. Remember, the questions that we're doing here are not necessarily about helping you to understand how to solve that particular question. My interest all the time with every question that I'm doing is to open up your brain to possibilities that you might encounter and how you need to align your thinking when you're dealing with these questions. My interest is on helping you with the concept, because these questions will not come back. They won't come back, but the concept will always follow you. So my interest here is on helping you to understand how do you align your brain when you're dealing with analytical geometry. Remember, it is not only analytical, it also engages other concepts of math, which is where you guys always struggle. So you want to see what is going to be happening. We've got very nice things that are going to be happening on today's show based on the questions that I've received so far. If you haven't sent your question, send it through. I want to help you to understand how do you work with that. Okay, cool. So let's, first of all, before we even start talking about Pendulo's question, I just want to highlight a few things. We are looking at analytical geometry because it's very important for us to show you where the problem is. And I know there's a lot of educators who also watch the programs. Please advise your kids to also pay attention to what I'm going to say now. Analytical geometry is not a problem. You guys know analytical geometry. If this was a movie, the main actor or the main actress would be analytical geometry on today's program. What you need to know as far as this is concerned is how to work out the distance between 2 points when you're given coordinates. And this is something you've been doing since grade 10. You need to know how to work out the coordinates of the midpoint, which is a point between 2 points anywhere on the Cartesian plane. You also need to know how to work out with the gradient and the shenanigans that involve the gradient. For example, what happens if you've got 2 points and you want to work out the gradient of a straight line? What happens if you've got parallel lines, their gradients are the same? When you've got perpendicular lines, the product of their gradients give you -1 and all those things. You need to know this, which is very interesting because you guys happen to know how to work with all that. And then, of course, you also need to know how to work out the equation of a straight line, which you can be able to do using a gradient and a random point. And you also need to know how to work out the equation of a circle that could be either positioned or centered at the origin or anywhere else. If you know how to work out all these 5 things, you understand analytical geometry. So why do people struggle when it comes to analytical? Why are you not succeeding to ace this concept, particularly if you are writing an exam? Because this is worth around 40 odd marks in a typical grade 12 final exam paper. So you want to make sure that you ace all those marks. The problem is all the supporting cast, like all the other topics that you need to pay attention to, right? The other topics that are necessary, which we want you to pay attention to. They are important because they participate in helping you to answer the questions that you are going to be faced with. Concepts such as algebra. Algebra is a big one. Your ability to solve simultaneous equations, those kinds of things, right? Your ability to solve any equation for that matter, whether it's a linear or a quadratic equation. How to square a binomial, you see. How to add like terms. Those kinds of things. All those basics of algebra are important. And in this case, there's another important basic that is called completing the square that we use when we're dealing with the equations of a circle. So it's not because you don't understand analytical. It's the other topics that are causing you problems. And you're going to see how these work hand in hand with analytical to help you to solve problems. The other one that is popular in this case is Euclidean geometry, right? And I'm going to say this to you. If you ever forget a lot of the geometry theorems that you learned in grade 11, the ones that involve circles, the one that is most important that I want you to make sure that you go back and you revise is the one that talks about the fact that if you've got a circle and you've got a tangent, that tangent will be perpendicular to the radius. Because from this, we can then link it up with the shenanigans of a gradient, where we're going to say the gradient of the first line times the gradient of the second line equals to -1. It's one of the most important, the basics of fundamental concepts that play a big role in solving the problems that we're going to be dealing with here. Right. The next one is maybe you might be dealing with a situation where you've got 2 tangents that are drawn from the same point. You guys need to know that they're equal in length. And all the other theorems, they're very important. They come in at some point and you guys struggle to solve the problems, not because you don't understand analytical, but because you're struggling to link it up with the other topics. So please pay attention to that. The other one that is very popular as well is trigonometry. You could find yourself using trig to either work out maybe the area of some quadrilateral they have or a triangle that they have here or any polynomial. You could be finding yourself trying to work out the lengths of sides using the sine rule or the cosine rule. So any of these concepts from trig might also play a role. So please do not shut them out of your thinking things that you're thinking about as you're trying to figure out what to do. So trig also plays a big role. Maybe even measurements also plays a big role. In grade 10, we learned a lot when it comes to measurement. We learned even properties of quadrilaterals. What makes something a square? What is special about a square? So all the properties of quads, like a square, the properties of a rectangle, the properties of a rhombus. You know, a rhombus is not the same as a square, or any parallelogram. All these parallelograms, they also come up in the exams, and they want you to know what are the properties of a square. If I say prove something is a square, you're going to use concepts of analytical geometry. But if you don't know what a square is, then you can't solve the problem because you wouldn't know what you'll be dealing with. The other one is, for example, a kite. You guys need to know what is a kite, or a trapezium, a trap. If you know what all these are, they actually help you to ace your analytical geometry. So the reason why I'm doing this is because a wise man once said, if I had 7 hours, right, to chop down a tree, I'll spend the first 6 hours sharpening my axe. So it's important for us to make sure that of all these 7 hours that you might be having to chop down the tree, we spend the first 6 discussing what is going to happen or sharpening your axe, right? It's very important. Don't rush into working with the concept of solving the problems. It's important for you to understand what is necessary. When you understand what is necessary, then you can be able to think along the relevant lines to solve the problems that you guys have here. One of the things I also want to talk about before we even continue solving this is the first 3-4 questions of analytical geometry. You guys are good at them because they are uniquely based on analytical. But once we start engaging what we call complex problems that engage more than one concept of math, you guys struggle. It's like, imagine if your granny was asking you to bake muffins for them, right? You're looking for the ingredients, you are able to bake. Let's just assume that you're good at baking muffins, right? If I ask you to bake muffins and you can bake muffins, you are able to bake muffins, provided you've got the ingredients. But if there are no ingredients and I ask you to bake the muffins, for some weird reason, you guys don't think about the idea of saying, okay, for me to bake the muffins, I'm gonna firstly have to go and buy the ingredients. When I've got the relevant ingredients, then I can be able to bake the muffins. When we've got those kinds of questions, you guys stop writing, and I don't know why that happens. So I hope on today's episode, we're going to also iron out those kinds of flaws to say, look at what we're dealing with. We are looking at finding something, but we don't have it. So we need to do something first before we can come and do what is required of us, right? But then, of course, if you don't know what is needed, what the ingredients are supposed to be, then you can't be able to go and look for something that you don't know. Very important for you to keep that in mind. Right. Okay, on that note, let's have fun. Let's have fun. The fun is about to begin now. Let's go to the first question. That was Mpendulo's question. Let's look right into this question and help you guys to understand what is going on with Mpendulo's question. So Mpendulo's question reads as follows. It says here, the equation of a circle with the center A is x squared plus y squared plus 5 equals to whatever. And there's another circle here with a different equation. So they are asking us to prove that the two circles touch each other, something that is not required or that is not allowed during these trying times of COVID-19. Right. So we want to prove that the two circles touch each other. There are two circles that can be on the Cartesian plane, the other one here, the other one there. We want to know, they're asking you, they're telling you that these circles are going to touch. So they want you to prove that these two circles touch each other, obviously externally. All right, so let's see what the story is with this question, right? It's Mpendulo's question. Thank you, Mpendulo, for sending this question. It's an awesome question indeed. It speaks to us about the whole concept of proving that two things indeed touch, two circles in this context. So let's draw the first one. I'm going to actually separate it like this so that you guys can see what is going on, right? The first circle is the one that is centered at A. So circle with a center at point A, and there's another one which is has a center at a different point, which is, according to Mpendulo's question, at B. The one that has a center at A, its equation reads as follows. It says x squared plus y squared plus 5, right, is equal to 16x plus 8y minus 30, right? The other one, the second one now, like the second one, which is centered at point B, has the equation 5x squared, right, plus 5y squared is equal to 25. So these are two circles that we need to deal with. Okay, cool. Now, if you look at the first one, right, the one that has a center at point A, you'll agree with me that we can't be able to see what the center and the radius of that circle is if we don't write it in standard form. The standard form is the format x minus something squared plus y minus something else squared equals to r squared, right? Why am I saying this? Well, the idea around the whole concept of proving whether two circles touch each other or they do not touch each other lies in working out the distance between their centers. So I'm going to have the first circle, okay, and the second one, and I want to figure out, do the distance between their centers equal the distance between the distance that you get when you sum up the radii, right? Okay, so the first thing I'm going to do, I'm going to try and convert center A, the circle with the center A, to the standard format, and then work it from there. Okay, cool. So for me to do that, I need to use what we call the concept of completing the square, which means it's a grade 11 algebra concept. So I'm going to group all the x's together. So I'm going to have this x squared, that is plus 16x. When you subtract 16x on both sides, this is as good as transposing or taking 16x to the left is going to sit next to my x. And then on the y's, I also have that y squared. I want 8y to also join y on the left, which means I'm going to have minus 8y, right? And all the numbers, all the constants, we call them like terms in mathematics, I'm going to group the 5 and the 30 by taking 5 to the right. Mathematically, we say you are subtracting 5 on both sides of the equation. So when I subtract 5 on both sides, that 30 and that 5 together, it's actually negative 30 and negative 5 will amount to negative 35. Okay, cool. Now I've got all the x squared minus 16x, I've got y squared minus 8y equals to minus 35. Now I'm going to begin the process of completing the square, which is something that comes from grade 11, algebra, right? What do you do when you're completing the square? Well, you focus on these ones. You focus on the axis. I'm going to add a third term for the axis. How am I going to do that? I'm going to say, okay, you have x squared, you've got minus 16x. So you add a term here, right? Which is half of that minus 16. Not half of 16, half of minus 16. You need to focus at both the sign and the number. And you'll agree with me that I'm actually neglecting the x as I'm working out the half of it. So what is half of minus 16? It is minus 8, which I'm going to simply put here and I'm going to square it, right? Plus, the y's are going to actually experience the same thing. I've got y squared, I've got minus 8y. I'm adding something interesting. What is that? It's going to be half of that number that you see there. Half of this number. Half of minus 8 is minus 4. So I'm going to simply have minus 4 here and I'm going to square that. But this is math. And we also have a law of conservation in mathematics that says what you do on the left, you need to do on the right-hand side. So on the right-hand side, I always had that minus 35. Because on the left, I added negative 8 squared. I also need to add negative 8 squared here. Because on the left, I added negative 4 squared. I also need to add negative 4 squared on the right-hand side as well. Right. I hope you guys can follow what is going on there. Okay, then from the axis, in order to complete the square, you take a square and a square, you make a square. I'm simply just factorizing the first 3 terms. X squared minus 16x plus negative 8x. I normally tell my learners, don't touch that minus 8 squared and take it to positive 64. Just create a bracket, take the term from a square from x squared, and take that minus 8 with its sign and create a square. And then I'm going to do the same thing for the y's. I've got y squared minus 8y plus negative 4 squared, which is supposed to be 16, but I'm not taking that minus 4 squared to 16. I'm just going to take a square from y and the term of a square from that 4, and I'm going to make a square. Now, on the right-hand side, I just have numbers. So I'm going to call on my calculator and work it out. What is negative 35 added with negative 8 squared added with negative 4 squared? What you get when you do this, you simply end up with a value of 45, right? So this is as far as this circle is actually taking me. Now, what does that look like? Well, according to what we're sitting with here, we simply have on the Cartesian plane a circle, right? We have a circle which has a center, right, with the coordinates 8 and 4, and that has a radius, not of 45, but the radius of that circle, right? The radius of that circle is the square root of 45, because what you're looking at here, beautiful people, is not r, but it is r squared. Your r squared is 45. Now, if you want the radius, you need to take the square root on both sides. I normally tell people you need plus minus, but we're dealing with measurements here. And the radius of a circle will always be a positive quantity. So that's the square root of 45. Take your calculator, you try to work out what is the square root of 45 for the radius, you end up with 3 root 5, right? So this is actually 3 root 5. It's the radius of this first circle. Okay, cool? Right, let's go and try and see the second one. Pendulo, I want you to see on the second one. This is supposed to be the circle that is centered at the origin, but we don't have the equation of a circle with a coefficient in front of your x squared and your y squared. So the first logical thing we need to do here is, of course, get rid of those coefficients. So I'm going to divide by 5. If you divide one term by 5, all the terms must be divided by 5. We end up with x squared added with y squared is equal to 25 over 5. I hear somebody saying the answer has to be 5. So what kind of a circle is this one? Well, this is the one that is centered at the origin. Let's try and plot that out. I've got the Cartesian plane, and then the circle that we're talking about now has a center at the origin, and it looks something like this. Of course, nicer than what I have here, right? Okay, cool. So now, what is the story with the center? The center is OO. We're happy with that, the origin. But the radius, the length of the radius of the circle. The radius of the circle is the distance from the center to the circumference, and it is not going to be 5. Remember, what you are looking at here is not r, it's r squared, because this is simply x squared plus y squared equals to r squared. Now, if r squared is equal to 5, that means that my r squared is 5, so the radius is going to be the square root of that. That's why my r here is going to be the square root of 5. Beautiful stuff. Okay, cool. So I've got my circles drawn both on the Cartesian plane, right? So we're asking you a simple question. We want you to prove that they touch each other. So if I had to superimpose, scientists understand that term much better, which means if I had to put both those two circles on one Cartesian plane, the examiner is claiming that they would look like this, right? The examiner is claiming that they would look like this. First, you're going to have the white circle, which is the one that is centered at the origin, right? The examiner claims that you're going to have the white circle that sits something like that on your Cartesian plane, right? And you're going to have the yellow circle appearing somewhere next to it, right? Of course, with a bigger, it's going to be much bigger because its radius is bigger than the first one. So the examiner is claiming that this is actually how the whole thing actually looks, right? I hope you guys can follow. The center here is 8 and 4. Okay, cool. So how do you prove that these actually indeed do touch each other externally, like what I have done here? What we have to do is just to show that the distance from here to there, which is the radius of the big circle, which we found to be equal to 3 square root of 5, right? Added with the distance of the radius of the white circle, which I'm going to call small r, which happens to be the square root of 5. That whole distance, the sum of the radii, right? We want to prove that small r plus big R is the same as the distance you get when you move from the center of the first one, which the examiner told us to be B, to the center of the second one, which the examiner told us to be A. So if small r plus big R is equal to the distance from A to B, then it does mean that they touch externally. So that's what we have to do. So far, what do we have about the sum of the radii? The small radius is root 5. The big one is 3 root 5, right? So the left-hand side, we are getting 4 square root 5. So we just have to prove that if I work out the distance from B to A or from A to B, I'm going to end up with the same length of 4 root 5. Okay, what are the coordinates of B? Well, B is the origin, which is O and O. Let's work out the length of AB using what? The distance formula. There's analytical geometry coming in now. Okay, AB is the square root of x at A minus x at B squared plus y at A minus y at B squared under the square root sign. This is the distance formula. It's available in your formula sheet. So the square root of course, the x at A is 8 minus the x at B, which is 0, squared plus the y at A is 4 minus the y at B, which is 0 squared. Okay, cool. Now, if I work out all that, what do we end up with? Let's call the calculator. Okay, that's 8 squared. We're looking at the square root of 8 squared, which is 64, plus 4 squared, which is 16, 6, 7, 8. This is the square root of 80. And I bet this is also going to be 4 root 5, which means since they are equal, you see we're getting the same length of 4 root 5. 4 root 5 equals to 4 root 5. Therefore, it means, right? the circles touch each other, right? Touch externally. All right, very important for you to keep that in mind in Pendulo. I hope this actually helps you to understand. You just had to try and imagine these circles. They were not even drawn on Pendulo's question. They just gave us the equations. So what did we have to do? We had to just convert those equations to the standard form. Why? Because we want to see the center and we want to also see the length of the radius of each of those circles. Then when you have them, if I try to superimpose them and put them on the same set of axes, this is what we ended up with. You can see the one with the center at point A has a radius of 3 root 5. The other one has the radius of square root 5. With that in mind, the distance from A to B happens to also be 4 root 5. Then it means because it's the same as the sum of the radii, we're getting the same story as what we wanted to work with. So this is actually a beautiful question, Pendulo. I hope you now see what you have to do. That's all you need to do. Work out the sum of the radii. If it is equal to the distance between the centers, it means they touch. But if the distance between the centers is bigger than the sum of the radii, then it means those two circles do not touch at all. But if the distance between the centers is smaller than the sum of the radii, it means those circles hug each other. They actually cross each other at some point.